Hello and welcome to the class of Structured System Analysis and Design and Software Engineering. In today's class, we'll discuss object-oriented design and methodologies. As discussed earlier, structured system analysis and design is a systematic approach used for designing and analyzing software systems using structured methodology and is based on structured programming principles. And object-oriented design and modeling is a structured approach to designing software systems using object-oriented principles, and it will help you to create scalable, reusable, maintainable softwares. Now coming to the basics of modeling. Why a model is important? Model is basically, in this context, is a simplification of reality. Model helps you to understand the system what we are developing. However, if the model is complex, then it is not possible to comprehend a system using a single model. So in that case, you may need more than one model to understand it. Also, models can be formal or informal. Okay. So if the project is more complex, a formal model is more important for you so that you can comprehend the system better and you understand the system to its entirety. Next, let us discuss about the principles of modeling. So how a problem is attacked and how do you shape a solution? These are the key objectives when you choose a model. Okay, and not a single model is sufficient, as mentioned before. Even a non-trivial system is best approached through nearly independent models. All these models are connected to the reality, and every model are expressed in different levels of precision, but together it will give a sense of entirety, and that should be enough for you to comprehend the model completely. Next, let's understand what is unified modeling language. So unified modeling language, or UML, is a standard language for modeling software systems. It serves a bridge between the requirement specification and the implementation, and it will provide the means to specify and document the design of a software system. Okay. You don't need to know programming languages for implementation of the UML based designs, and primarily used for object oriented programming and development of such systems. So as discussed earlier, object oriented design and modeling is a structured approach to designing software systems using object oriented principles. And so what are those four fundamental object oriented principle or OOP? So there are four principles, namely encapsulation, which means bundling data and methods together; abstraction, which implies that hiding the implementation details. Also, there is inheritance, which means allowing classes to derive properties and behavior from other classes. And also there is polymorphism, which means enabling objects to take multiple forms, like method overloading and overriding. So now, unified modeling language provides you a visual representation of the model, and UML provides structured and standardized diagram to describe system behavior, system structure, and interactions. And object-oriented design methodology, or OODM, relies heavily on unified modeling language. Now, next we discuss about the notations used in unified modeling language. First, we'll discuss about class. A class provides a description of a set of objects, and they share same attribute, operations, relationships, and semantics. So for example, if you take a window which has origin and size as attributes, and open, close, move, and display are the operations that can be employed on a window. Next, let's discuss about interface, which is a collection of operations that specify service of a class or component, and it provides externally visible behavior of that element. So for example, here we have I spelling interface. How the spelling checker is implemented, that is irrelevant, and the external behavior of the system which is exposing through the application program interface or APIs, that will provide you the behavior of the content or element. A collaboration defines an interaction. So how a particular element work together with other elements and provide a cooperative behavior. The next notation is use case, which provides a description of a set of sequence of actions that a system performs and yields an observable result. For example, user places order of something from the market, say, So at the end of this action, there is an order which is created. So it is an observable result. Active class is a class whose objects own one or more processes or threads. So you can see event manager in this case is an active class. So event manager will be able to initiate control activity. It will list all the events in event list attribute. It will be able to suspend and clear all the events using flush. So next notation is component. Component is a physical and replaceable part of a system that conforms to and provides the realization of a set of interfaces. So a part of a system and it provides the realization of a set of interfaces. A node, which is a physical element, it exists at runtime and represents computational resource. For example, in this case, server. Server is a computational resource, and that is denoted using a cube. Okay. And the interaction, which is a behavior, comprising of a set of messages exchanged among a set of objects. So, interaction refers to how objects communicate with each other to achieve system functionality. And it represents the flow of messages between objects to perform specific tasks. So, here in this case, an interaction of display is denoted with an arrow. So an object like a panel displays a string. So it has to achieve this specific purpose of displaying a particular string. So that is being depicted in form of interaction. Now, when we talk about state machine, it is a behavior. It specifies the sequence of states an object or an interaction goes through during its lifetime in response to events. So basically, we need to model how object transitions between states based on events and conditions. Okay. And there are different conditions of an object. You may think about some states like idle, processing, and completed. So if it has nothing to do, it is in idle state, it is doing some work, it is in processing state, and it is finished with processing. Then it goes to the complete state. Transitions means movement from one state to another. Okay. And events are those which triggers these transitions. Okay. And there will be certain constraints that decide whether a transition should occur or not. So all these things are depicted using state machines. So here a waiting state is denoted with a rectangle with round corners. So waiting is a state and that object is in this state for a particular time. And it can move to another state through an event when an event is triggered. Next we have package. Package is a mechanism for organizing elements into groups. So for example, we have number of business rules that can be put into a package. So a group of rules which are very similar in types, they are organized into a package. A note is here representing some comments which are attached to an element or collection of elements. It is an information which is attached and is not related to the diagram core. It is some additional information attached to it. Okay, some annotations provided for better understanding. Then we go to the relationships. We have two terms here, dependency and association. Dependency means a semantic relationship between two things in which a change to one may affect the semantics of other. Okay. We'll discuss in detail afterwards about dependency. What is association? Association is a structural relationship, a link or connection among objects that is being depicted using association. So employer-employee, there is a connection, there is a link between them. So that is depicted using association. But there are several types of association in object-oriented modeling. So generalization is something like is a relationship where objects of a specialized element or child are substitutable for objects of the generalized element. The parent shows a general behavior, the child shows a specialized behavior. And the realization is a semantic relationship between classifiers. One classifier specifies a contract that another specifier guarantees to carry out. So generalization is a process of extracting common characteristics from two or more classes and creating a general superclass. It represents an easy relationship between classes. So in this case, superclass or otherwise called as parent class, it contains shared attributes and behaviors. Subclass or the child class inherits from the superclass and may have additional features. For example, let's consider vehicle to be the general class, which is a superclass. Car and bike inherit from vehicle. So vehicle has common attributes like speed, color, which car and bike both can inherit. So we can have some similar kind of examples like animal, and then dog, cat and elephant as child class, shape as the parent class, and circle, rectangle, triangle is the child classes. So on the other hand, realization is the relationship between an interface and a class. So here the class implements the behavior defined in the interface, and it represents a can-do relationship. For example, payment gateway and PayPal. Okay, so payment gateway here is an interface which is basically an abstract contract. PayPal implements payment gateway, and PayPal provides concrete logic for methods like process payment. So we can have some other real world examples like vehicle, which can have an interface, and car, bike, truck are the classes implementing that. Database driver once again can be an interface, and MySQL driver, PostgreSQL driver, this can be implementing it. So we can now make a comparison between the two. That is generalization and realization. So by definition, generalization is inheritance-based class hierarchy, and realization is inheritance to class relationship. In case of generalization, the relation type is easier, whereas in case of realization, the relation type is can-do. In case of generalization, an empty triangle arrow is used, and in case of realization, a dashed arrow is used. So as you can see in the diagram. So now let's move on to the next slide. It talks about different diagrams that are used for the modeling purpose. A diagram is a graphical representation, set of elements rendered as a connected graph of vertices and arcs. So here vertices are the elements or things, and arcs will denote the relationships. Number one, class diagram. Class diagram shows a set of classes, interfaces, collaborations, along with their relationships. Object diagram shows the set of objects and their relationships. Use case diagram shows the set of use cases, actors, and their relationships. Okay. And then there are interaction diagrams. Interaction diagrams are basically meant for displaying the interactions among the objects and their relationships, including the messages which are dispatched among them. Sequence diagram is an example of interaction diagram. sequence diagram emphasizes the time ordering, whereas collaboration diagram, that is also an interaction diagram, it emphasizes the structural organization of the objects that send and receive messages. A state chart diagram will show the state machines. It consists of states, transitions, events, and activities. So states are different conditions of an object. Transitions are movement from one state to another. Events are the triggers that causes the state transition. Okay. Activity diagram is a state chart diagram which shows the flow from activity to activity within a system. We'll discuss more on that. Component diagram shows the organization and dependencies among a set of components. Deployment diagram will show the processing nodes and the components that live on those nodes. So it's how you deploy the system. In which server, which machine, you will deploy the system. What are those components will be deployed in which system? How we will configure them? All the details will be modeled using deployment diagram. So here is an example of Hello World class, where the name is Hello World, and it does the operation paint. So let's dig deeper into it. So how should we model this? The paint operation is to provide the annotation of Hello World at the position 0, 10 in a panel. Okay. So we have the class called Hello World, that is the name, and the operation called paint. Okay. So suppose this was the implementation of Hello World. So Hello World extends Java applet, and it has a method called paint. And inside method you have draw string. For drawing the string Hello World at position 10, 10. So how do you provide it in form of diagram? So there is a generalization of the Hello World class from applet. Okay, so applet and graphics classes are shown elided. Graphics is the class which is very obvious that paint will use the graphics class. So there is a dependency between these two. So that is a broad level diagram. So if we go into little deeper to understand this, there is a class inheritance diagram. So it shows that Hello World is an applet. An applet is basically a panel. Panel is implemented in form of a container. Container is a component, and a component is also an object. The component provides an interface, namely image observer. Okay. So how do you package this? So in Java, you have the Hello World applet implemented. The graphics is provided by AWT package. Okay. And there is also lang, which will provide the language support. So all these things are part of Java, and your hello world will be packaged